that had joined me before, welcome back. We are here, we're in the building, and I just want to make sure that everything is going fine. So as you guys can see, we are going live dually on YouTube. So those of you guys that want to catch this video on replay, you by all means, you sure can do so. All right, so for those of you all that are here, if you're new to me, don't forget to share this video out and subscribe to my YouTube channel, but also make sure that you follow me here on this platform as well on TikTok, because we're going to do this every Monday, Tuesday, Wednesday, Thursday. With summer school starting for many students across the country, they're having to take chemistry during the summer, whether they're trying to play catch up or if they just want to repeat the class because they didn't like the grade that they got. Either way it goes, we're here Monday through Thursday at 12 noon or 12:15 Eastern Standard Time. Now, here's something else that I want you guys to know about. I will be going live in the evening times as well, because I do know that some of you all may need help in the evening time. So I will be doing it during the day, during lunchtime, and in the evening time, okay? So if you guys are ready, I'm ready. Let's go ahead and get into this lesson for today. What I have on the board are some examples, or this lesson is going to deal with significant digits, okay? Significant digits, and these are the notes that I typically give to my students. So as you can see here, significant digits determines whether or not a measurement is accurate or precise, and we must rely upon the instrument that produced it. So in other words, if we're weighing things on a scale, we're going to use that number, but sometimes the numbers aren't always clear. As a matter of fact, let me go and demonstrate this as an example. I'm going to get a beaker so you all can see. And let me go ahead and turn the light on for a second, because I know a lot of times when we are dealing with significant numbers, significant digits, the numbers don't always match up, okay? All right, so if we take a look at this beaker here, matter of fact, I'm going to need to turn my camera on, but I'll do a demonstration for YouTube later. But as you guys can see, I have a beaker here, all right? And this beaker has numbers on it. Now, these numbers aren't always accurate in terms of your measurements with your liquids. So then if you get a scale, the scale may tell you a better number, a better value. Same thing with this pH scale, this pH meter here. So if I'm measuring a certain liquid, okay, based on the measurement, that would tell me a certain value, okay? So when it comes to significant digits, significant numbers, you have to be aware of the fact that these numbers do change based on their precision and or accuracy. Now, there are some rules that you do need to follow, and I'm going to zoom in on those rules so you will know what those rules are, okay? If you have questions, by all means, let me know. I will be doing tutoring again this evening. So for those of you all that may have to hop off, that's fine. Okay, that is fine. So for this first part right here, as we walk you guys through it, it says all digits 1 through 9 inclusive are significant. So that simply means that if you have a number like 354, all three of those numbers are significant, okay? All three of them are significant. If you have a number like, 123, all three of those numbers are significant. Let's say that I gave you a number like 4,524, then all four of those numbers are significant. So in other words, the numbers 1 through 9 are inclusive to being significant. However, if you look at statement number 2, zeros between significant digits are always significant. Keep that in mind of where the zeros are located. So in this particular example right here, if the zeros are sandwiched in between two other significant digits, then the entire number counts. So that means 3009 has 4 significant digits. If I gave you a number like, let's say 47,002. Okay? $47,002. Guess what? All of those numbers would actually count. So in this case, I would have a total of 5 significant digits, okay, in the 47,002. Again, if the zeros are sandwiched in between other significant numbers, that's where you would make sure that you keep that in mind. Now, here is the catch though. In statement number 3 says trailing zeros in a number are significant only if the number contains a decimal point. So that's something else you have to keep in mind. And let me tell you guys why you got to know these things. Because when you do your homework on these portals, whether it's Mastering Chemistry or some other learning management system where it automatically grades you, if your numbers aren't in the proper significant digit setup, your answers will be wrong and you won't even understand why. But it's because of these values here. So in statement number 3, you have 100.0. Guess what? Those trailing zeros count because there's a decimal there. So in this first number here, the 100.0, okay, has 4 significant digits. But if I gave you 100 and there isn't a decimal present, then you would only have 1 significant digit. Okay? So again, when it comes to these significant digit rules in chemistry, you've got to make sure that you follow them. Some of your teachers are not going to tell you only do 2 numbers after the decimal, only do 3 numbers after the decimal. You've got to follow these significant digit rules in order to be on point when it comes to these software systems that automatically grades you, okay? They're not going to know that you don't know how to do significant digits or that you do. You have to be on point with knowing these rules. Now, in statement number 4 right here, and let me zoom out a little so you all can see that rule. Zeros in the beginning of a number whose only function is to place the decimal point are not significant. Trailing zeros are not significant. So you're probably saying, okay, wait, what? I don't understand that. Trailing zeros in the beginning of a number whose only function is to place the decimal aren't significant. So that means if I look at a number like this right here, where I have 0.000079, only the 7 and the 9 are significant. So in this case, we only have 2 significant digits. So again, only the trailing numbers that are there, those zeros, they do not count. But when you hit that first significant digit and any number that comes after it are significant. Now, when you get to the zeros, on the other hand, like in statement number 5, and statement number 5 says zeros following the decimal and significant digits are significant. So what does that mean? That means if you have a bunch of zeros that lead in the front, and then you have your first significant digit followed by a 0, that means all 3 of those numbers count. That means you have 3 significant digits. On the other hand, if you just have like a 0 and then the first significant digit followed by these other zeros, again, all of those zeros count and you have 5 significant digits. So again, if the zeros are placed in front, like in example number 4, those zeros do not count. If they come after the significant digit, then they do. Okay? I just have to say that over and over and over because a lot of times students get this confused, especially when we do homework. So what I'm going to do now is go through an example problem with you all that highlights this, okay? And here are some examples here. That's right, Jada. Very good. Trailing zeros. That's right. Trailing zeros. That is correct. Now, let's do a couple of examples right here so we can see if we're all on the same page. Okay. So you all know, since this is in Microsoft Word, they always make these little blue lines. So just ignore that. Just look at the number itself, though. We have 0.03. How many significant digits do you see? In this case, there's only 1. And the significant digit is that 3 right there. because the numbers that come in front are trailing, so they do not count. Okay? Look at number 2, 0.030. In this example here, you have 2 significant digits. Why? Because that first significant digit there, that 3, that counts, and then the 0 after it counts, but also because there's a decimal there. And if you need to refer back to the rule, let's go back to the rule that stated as such. Right here, for rule number 3, no, I'm sorry, rule number 4. If you look at it, rule number 4, remember, trailing zeros that are in front of the significant digits do not count. So that's what rule number 4 is based upon for number 1, for problem number 1. When we look at problem number 2, it's based on the same rule, except there's an exception to the rule for number 5. Rule number 5 says that if there's a trailing zero, but there's a decimal there, the only time the zeros count is if it's after a significant digit. So in this case, 0.0, those 2 zeros don't count. 30 does count. And that's where we end up with 2 significant digits. All right, number 3, 701. This is number 2's rule, where the 0 is sandwiched in between 2 other significant digits. So therefore, 701 counts. So you have 3 significant digits in this particular example. Number 4, 701.0. All 4 of those numbers count. So in this particular case here, we end up with 4 significant digits. Now, in number 5, we have 5,000, okay? But without the decimal. 5,000 without the decimal means we have 1 significant digit. So if I gave you 5,000 here, okay, like in number 5, I only see 1 significant digit. But if I gave you 5,000 and then I put a decimal on the very end, then that would give me 4 significant digits. In this particular case, that means the 5, the 0, the 0, the 0 here, all 4 of those numbers would count, and you would have 4 significant digits. This is a great segue to number 6 over here. Number 6, you have 8,000 with the decimal present. So guess what? You're going to have all 4 of those numbers counting because there's a decimal at the very end, and that means all of those numbers are significant. Number 7, we have 5,032.00. Now, you remember what we said, because there's a 0 here that's sandwiched in between the 5 and the 3, that 0 counts. And because there's a decimal present that comes after significant digits, that means all of these numbers count. So in this case, we have 6 significant digits. Thank you guys so much for the likes and the shares. I appreciate that. All right. And yes, make sure you guys continue to tap that screen because TikTok needs to know that we are over here giving away free chemistry tutoring during the summertime over the next 5 weeks. Because I know typically summer school lasts anywhere from 5 to 8 weeks. It depends on where you are. Number 8, we've got 0.00003. Guess what? You can have all those zeros, but until you hit the first significant number here, which is that 3, that's the only one that's going to count. So in this case, we have, I put the 3 there, but I meant to say 1 significant digit. Okay. Now, the next example for number 9, we have 0.6050. Here's the deal. That 0 that's sandwiched in between the 6 and the 5 counts. So therefore, the 605 counts, but guess what? So does this 0 on the very end. So therefore, you have 4 significant digits in that particular number. Thank you, Sweets Turkey Barbecue and Precious. I appreciate you guys. Yes, you all make sure y'all join in tapping that screen. Tap, tap, tap. It doesn't cost you a thing but your finger to tap, tap, tap. Number 10. We've got 25,007. 25,007. Thank you, Steve. What you're going to see here is that, again, the zeros that come in between the 5 and the 7 count. So therefore, all of these numbers are going to be significant. So therefore, you have 5 significant digits right here. 5 significant digits. Now, let's take a look at number 11. 11, you have a scientific notation value, 4.25 times 10 to the negative ninth power. And same thing with number 12. You have 6.7 times 10 to the eighth power. Well, guess what? We don't concern ourselves with the exponents here, but what we do need to look at is the base number. So whatever the base is, the 4.25, that's what you go by. 6.7, that's what you go by. So in this particular case, in 4.25, we have 3 significant digits. And the number 12, 6.7, we have 2 significant digits. Okay. Any questions? If there are, we're going to take a second to get your questions answered while I grab my water. I hope you guys are staying hydrated during the summertime. Right here, you see I got my 3-liter bottle of water. That's important. Staying hydrated is very important. All right. We're almost up to those 3,000 likes. Let's keep it going. All right. Now, here's something else that you guys got to be aware of. When it comes to, okay, yes, hey, Jacqueline, yes, yes, yes. So with that number, anytime you have an exponent, let me write it right here. It was 4.25 times 10 to the negative ninth power, okay? Regardless of this being in exponent fashion, you only look at the base number, okay? The 4.25 is what you go by. So in this particular case, you have 3 significant digits, the 4, the 2, and the 5. So if we go back up here also to our rules, okay? Right here, it tells us all digits 1 through 9 inclusive are significant. So that simply means that if you have numbers 1 through 9 anywhere written down, that's going to count as being significant. So that 4.25 times 10 to the negative ninth power, we were only concerned about the base. Now, if we wanted to write this number in scientific notation, then we still will consider the same thing. The rule says these trailing zeros here do not count. They do not count. Therefore, you're only looking at the 4, the 2, and the 5. So you still have 3 significant digits. Oh, great, 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 Jacqueline. Great, great. I'm glad you got it. Okay. Now, here is the thing. When it comes to significant digits, oh, you're welcome. You are so welcome. The thing you have to recall also, guys, when it comes to significant digits, you have to remember that there are rules when it comes to adding and subtracting. Okay, let me go back before I get to that part. So Precious says, if 12 had a positive exponent, would the decimal point still be in place or does it not matter? Ooh, very good question. Let's go back to that one. Very good question. So here is the deal. And it depends on what you're working with, okay? So let me explain what I mean by that. So for instance, if you have 6.7 times 10 to the 8th power, that means you're going to move your decimal 8 places to the right. So here we go. 1, 2, 3, 4, 5, 6, 7, 8. Now, some books are going to tell you that if you place your decimal at the very end like this, and you fill in those little lumps with zeros like this, then all those numbers would count. And let me go ahead and write this out. 1, 2, 3, 4, 5, 6, 7 zeros. 2, 3, 4, 5, 6, 7. That means in this case, if you put the decimal at the very end, that means all of these numbers would count. But typically, you go by what you have initially. That is the base number, the 6.7. So even though you moved your decimal to the right 8 times to the right, some books will tell you to leave the decimal off, and some books will say put the decimal there. However, you typically go by the base number to determine your actual value, okay? Which in this case, the 6.7 has 2 significant digits. You're just simply writing it in decimal form here, the 6, 7 followed by all those zeros. Oh, you're welcome, honey. You're welcome. So yeah, you just want to keep that in mind that you go by the base number. The base is going to tell you what you need to do. Even if you take it out of scientific notation and put it in decimal form, you still want to go by the base. And that means I'm going to have just 2 significant digits. Now, here's the deal. I'm glad you guys are asking very good questions, because when it comes to your homework and doing calculations, things can go a little wrong. You can go down a dark path if you don't remember these rules, okay? So I'm zooming out a little so you all can see the rules with me, and I'm going to read it out to you. So when it comes to adding and subtracting, you've got to limit your answer to the least amount of digits that are after the decimal place. If there isn't a decimal place, you would say that there are 0 digits after it, and that will be your least amount, okay? So let me break it down for you. So I'm going to zoom into the number itself, or to the problem itself, okay? So you all can see what I'm talking about. So right here, you've got 152 milliliters plus 3.41 milliliters plus 2.7 milliliters. Now, you know that your calculator is going to give you 158.11, but that's not the correct answer, okay, in terms of what you would put on your homework problem set. If you're doing this on a software system where they say select the correct answer, you would not put 158.11. That's just too much like doing right. Instead, you would have to look at the least amount of digits after the decimal. So in 152, there aren't any decimals, so that's 0. 3.41 has 2 significant digits after the decimal, right there. And I don't know what happened to, the 2.7 right here has 1 significant digit here after the decimal. So the least is 0. And so, yes, you are correct, Jacqueline. 158 is the correct answer. Very good, very good, very good. Now, let's see if you all can help me out on this next one then, this next example where we are subtracting. You've got 55.46 minus 28.9. Now, our answer that our calculator gives us is 26.56. But what should the final answer be? What should the final or correct answer be? Okay, 27. Jacqueline said 27. Well, let's look to see how many sig figs you should have after the decimal. So right here, we have 2 significant digits after the decimal in 55.46. But over here in the 28.9, we have 1 significant digit after the decimal. Okay, Jacqueline said, oh, wait, 26.56. Okay, yeah, that's the number that your calculator gives you. But how many numbers? Yes, very good, Jacqueline. That is correct. 26.6 is the correct answer. That's right, because you should have one significant digit after the decimal. And voila, you got that correct. Okay. So before I show you the rule for multiplying and dividing, hey Shabazz, how you doing, honey? How you doing? Let's move to a practice problem because the thing is, I want to show you, I want to make sure that y'all can practice a skill set before we actually do the problem itself. I mean, before we move on to multiplying and division rules. So let's do number 3 together, 3 and 4 and 6 and 8. Okay, so those are the 4 that we're going to do, okay? So 3, 4, 6, and 8. Now I'm going to actually plug up my calculator so you all can see me do this together. So that way you all can tell me the correct answer. So I'm going to write what the calculator says versus what you should say for your final answer. Okay. So let me zoom out a little so I can show you all how I'm writing the answers out. Okay. So for number 3, we've got 12.01 plus 35.2 plus 6. All right. We get on the calculator 53.21. 53.21 milliliters. But is that the correct answer? If we go by our significant digits rule, it says to go with the least amount of significant digits after the decimal. So let's take a look. And you tell me, what should we do? Okay, correct. The answer, Jacqueline, is correct. It should be 53 because we have nothing after the decimal here with the 6, one significant digit here for 35.2, and 2 significant digits in the after the decimal in 12.01. So therefore, we should not have any decimals, and instead our answer would become 53 milliliters. Very good, very good. Number 4. Let's take a look at number 4. We've got 55.46, so let's plug that in. 55.46 minus 28.9. We get 26.56 on the calculator. 26.56 grams on the calculator, but what should be the correct answer based on the significant digits rule? Hey, Candace. So what should our final answer be? Okay, Jacqueline says 26.6. You are correct. Once again, very good. 26.6 is correct. Grams, 26.6 grams. All right, we moving and shaking. Let's look at number 6. Number 6. We've got 0.15 plus 1.15 plus 2.051. Again, our calculator gives us 3.351 centimeters. But if we go by our significant digits rule, what should the final answer be? 3.351 or something else? Correct, Precious. Very good. 3.35 is the correct answer. 3.35. And here's why. For those of you all that are wondering, wait, what? Here is why. Very good, Jacqueline and Precious. You have 2 significant digits after the decimal here, 2 significant digits after the decimal there, but you got 3 right here. So the least of those digits tells us I only need 2 of those numbers after the decimal, thereby giving us 3.35. Okay, let's take a look at this last example with adding and subtracting. right. Thank you so much for the follows, guys. So you've got 505, whoops, 505, zero, just don't want to do right. 505 minus 450.25. Again, our calculator gives us 54.75. Let's see if you all get this correct. Kilograms. Okay. Is that the correct answer? 54.75. If not, write your correct answer in the chat box. Okay, Precious put 55. Jacqueline also put 55. Whoop, whoop. Y'all are correct. You guys are correct. 55 kilograms. And again, here's why. In this first digit right here, there aren't any numbers after a decimal because there isn't a decimal present. But over here, you have two numbers that are after the decimal. Therefore, since you should not have any numbers after the decimal, that 7 right here tells this 4 to raise up to a 5. So that is why the answer is 55. Very good. Y'all are on it. Y'all are on it. Precious and Jacqueline, what are you guys taking chemistry or have you had chemistry already? Are you taking chemistry or have you had chemistry? All right. Now, okay, good. Oh, good, 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 good. Jacqueline, I got you. When are you taking your dental admissions test? And Precious, you just finished your college chemistry class this year. How did you do? Oh, got you, Jacqueline. June 25th. Oh, wow, all these dental students. That's what's up. Yes, Precious, you go. You go ahead. You go ahead. Listen, all my dental students don't be going out here doing none of that janky stuff with them veneers. All that stuff is going around tickety top top in social media. People wilding out on those veneers. And I'm sorry, I'm just not going to anybody that you're not even in an official dental office for real. Yes, I got you, Jacqueline. Though, yes, if okay, good job, Sydney. Sydney Love or Sideline. Sydney. I think it's Sydney. Yeah, good. Congratulations on getting a B. Now you're headed to General Kim too. I got you if you need any help. And Jacqueline, you just let me know what you're gonna need help with too, since you are practicing for your dental exam. Like, tell me what things are gonna be stumping you. Okay. Now, I do know since you guys were able to get the adding and subtracting part, as we close out, we're going to do this last part right here that deals with multiplication and division. Now, with multiplication and division, it's a little different. Not quite that bad, but it's a little different. With adding and subtracting, you were looking at the what was after the decimal, but with addition is I'm tongue twisted, tongue tied. With multiplying and dividing, you are looking at the entire number, okay? So that means if I multiply 152 times 3.41 times 2.7, my calculator is going to give me this big number right here. But according to the significant digits rules, you have to do the least amount of the entire number. So right here, I have 3 significant digits. In this next value, I have 3. But in this final answer here, I only have 2. So that means that 1403, we don't care about the other stuff. 1403 will simply become 1400 cubic meters. Okay. Same thing, if you are dividing, you've got 55.46, which has 4 significant digits, divided by 28.9, which has 3. So if you have 4 significant digits in the first value, 3 significant digits in the last value, you only need 3 of these numbers. So let me highlight only the 3. That means, as you guys can already see from this answer here, the 9 tells that 1 to go up to a 2. And that's how we ended up with 1.92 grams per milliliter. Okay, so now let's practice these last few examples before we head out, okay? Now, we've already done the ones that are adding and subtracting. So now we're going to do the ones that are based on multiplying and dividing. So that's number 1, number 2, 5, and 7, okay? And again, I will be back on tonight at 7 p.m. Eastern Standard Time. So if those of you all that have friends that are needing help, tell them to come on over here on my channel this evening if they need extra help, okay? I teach oh, what are you teaching? Yeah, I'm doing general chemistry 1. I know a lot of students are taking chemistry during the summer, but if you have any specific topics, Jacqueline, that you want me to go over, by all means, let me know. You can DM me, the stuff that you need further clarity on, and I can help you. So you're literally 35 days out from taking your DAT, and you got this. You got it. So if we take a look at the first one, we've got 1.35. Okay. Oh, hey, Gabrielle. Good. When do you start summer school? Yes. Oh, next Monday. So you're actually in here for a reason. You're getting a head start on this information. And you can always come back to my YouTube channel. That way you can go back and watch the replays of all of my videos that I do when I go live. In this first number here for number 1, we've got 1.35 times 2.467. So again, my calculator gives me this big number right here, 3.33045. But remember, we don't need all of those numbers. We only need 3 of them. Because remember, the rule says that when you are multiplying and dividing, you go by the least amount. So I have 3 numbers here for 1.35, but I have 4 significant digits here for 2.467. So therefore, I only need 3 of those numbers. So my final answer will become 3.33 meters square. All right. Let's take a look at number 2. Number 2. We've got 1,035 divided by 42. So again, we get this number here. We get 24 point, and I won't write them all out because, I mean, at the end of it all, we don't need but only the least amount anyway. So I got 24.64, and I'll stop at the 2. But remember, we don't need all those numbers. So yes, that's correct, Jacqueline. The answer is 25. Correct. 25 meters to be exact. And here's how you know it's meters. You have a meter square on the top and a meter on the bottom. So you cancel one of each and you're left with just a meter right there. All right. Number 5. Before I plug this into the calculator, you guys tell me, how many significant digits should I have in my final answer? So I'm going to go ahead and plug this up, but you guys tell me, how many sig figs should I have in my final answer for number 5? So I'm going to go ahead and type this in, 0.021 times 3.2 times 100.1. So this is what I got on my calculator. 6.726. But okay, Jacqueline said 2. That is correct. I only need 2 of those numbers, so it's going to become 6.7 cubic centimeters. Okay? 6.7 cubic centimeters. All right, and this last example, this last one, we've got 150 liters cubed divided by 4 liters. So let's figure this one out. How many sig figs should I have in my final answer for this one? Look at the numbers. So you've got 150 divided by 4, and you get 37.5. Okay, yes, you should have liters squared, yes, as your unit. So this is the answer that I got, 37.5. But is that the correct answer? How many, okay, you said 1 significant digit. Okay, Luz said 1 significant digit also. You guys are correct, but what should the answer be in terms of having 1 significant digit? So I'm gonna scoot down here to give us some space. Hello, Starlet the Hollywood, how you doing? Long time no see. So if we got 37.5 and we only need 1 significant digit, what is this 7 going to do to that 3? It's going to increase. It's going to go up to 4. But you cannot just say that the final answer will be 4. You have to account for that 7's place. And so you would actually say 40 is the answer. Okay? But without the decimal, so 40 liters squared. And here's why. If you write 40 without the decimal, that's 1 significant digit. But if you write 40 with a decimal here at the very end, that's 2 significant digits. If you write 40 with a decimal and a 0 at the end, that's 3 significant digits. Yes. Yes, yes, yes. So it makes a difference. It really makes a difference. All right. So tomorrow I'll go over some other rules where it deals with rounding off. We'll just do a couple. Matter of fact, we could just do a couple of these with the rounding, because I know that a lot of times students, if again, the rounding is important for the problems that we just did a second ago. Okay. So, like for instance, if we look at an example like 86, number 1, 86, and I said to round off 86 to 1 significant digit, always put a decimal or a dot. I shouldn't say decimal, put a dot or highlight the first number that you need, and then the number to the right of that tells you what to do. So in 86, the 6 tells the 8 to go up. So this becomes 90. Same thing if we look at the second one. The 7, we only need 1 significant digit, so that 1 gets replaced with a 0, and it becomes 70. Number 3 is a little different. You've got 55, but that 5 to the right tells the other 5 to go up to a 6. But if you just left it as 6, that would be wrong. It is actually 60, but without the decimal. Okay, take a look at number 4. You've got 328. Number 4, 328. So right here, that 3 is the first significant digit. You only need 1 significant number, but that 2 tells that 3 to stay put. So yes, very good, Jacqueline. It becomes 300. That is correct. And let's see. Let's look at another one. You guys choose a number. We'll do. Oh, let's go down below to the decimal ones. We'll do number 12. Okay, let's look at number 12. You've got 0.0038. Again, we only need 1 significant digit, so that 3 says, all right, that's the number I'm going to change. So that 8 tells the 3 to go up to a 4. So this becomes 0.004. Okay. Very good, Adelia. Okay. Let's pick another random one. You guys choose a number that we can do, and let's practice another one. Number 9, okay. 8.921. Oh, good one, good one, good one. Number 9, 8.921. Yes, that would become a 9. Ironically, that's the answer to number 9 is 9. All right. Okay. Let's take those same numbers and let's do two significant digits. Two significant digits. So again, since I only need two of these numbers, what is that now going to tell the 6 to do? It's going to say go up. So you're going to end up with 870. But again, without the decimal, 713, that becomes 710. That 3 tells the 1 to stay put, but you've got to erase the 3 and replace it with a 0. Yes. Okay, what about number 3, 55? What do we do with that number? Yes, in other words, it doesn't change. It just stays at 55. Okay. Let's see here. That's right. It stays. Let's do number 5 is good. Let's look at number 5. Again, you only need two of these numbers. So this 3 tells that 9 to stay put, and you're just going to simply have 690. Yep. Let's do number 11. Number 11 right here. Again, you only need two of those numbers. So that 7 tells that 2 to do what? It increases to what? That is correct, Tay. Very good. Very good, Jacqueline. And Rochelle and Breeza, very good. 330. Very good. Very good. Okay. Y'all want to pick one more to do? Give me one more example. Pick a number. Number 13. All right, let's do it. Again, you only need two of those numbers, and guess what? This answer is just going to stay put. 0.00068. So in other words, it did not change. It did not change. All right. So again, for those of you all that just joined me, I will be going live again tonight at 7 p.m. Eastern Standard Time. So that if you guys have questions about anything, or if you wanted to hop back on for later, you can. I know that many of you guys are going to be taking chemistry next week. Some of you all preparing for summer school. Some of you all just got out this past semester with flying colors. Some of you all may not have flown very well, and you needed to do what? Take it over. But I'm going to tell you, you do not have to stress yourself doing summer school. If you come on with me every day, Monday through Thursday, I can help you guys out. It's free 99. But if you need more one-on-one attention, then you can hit that link in my bio and it'll take you straight to my website and you can learn more on how to get what you need in terms of one-on-one attention. Okay. Does anybody have any other questions for me before we close out? I thank you guys so much for hopping on per usual. Okay, you want to know when I do stoichiometry? Thank you, Breeza. Stoichiometry. So I do have some stoichiometry videos. I typically go on the order, like of summer school, like when summer school starts, and stoichiometry typically wouldn't take place until around my 3rd week doing this online chemistry, because I know that for summer school it is at a very it is at an accelerated pace, but I'll make sure to do some stoichiometry for you though. Yes, Jacqueline, I'll make sure to take care of stoichiometry for you. Stoichiometry deals with balancing equations for sure. So as long as you know how to balance equations, and if you know how to go from a gram to a mole, mole to a gram, those type of conversions using your periodic table, you should be good to go. Oh, you're welcome. Yes. So, guys, it is about 1:11 p.m. Eastern Standard Time my way, and I have got to charge my battery as well. But I appreciate you guys for hopping on with me this afternoon. I will be back tonight, 7 p.m. Eastern Standard Time. So if you all did not get your questions answered during this live, by all means, come back on this evening. Okay. Oh, you're welcome, Starlet Hollywood. And also make sure that you guys tell a friend and tell a friend and tell a friend. You all can go on my YouTube channel as well, and you can see all of these videos uploaded too. So if you didn't have a chance to stay on fully, you can go back and look at them as well. All right, guys, you all have a good one, and see you all tonight. Take care.